This is just, the lab you did on Wednesday. It's got a little bit of everything from 5.1 all the way up to 5.5, the most recent section. So the first couple problems here, what you're being asked to do here, just eyeball it, look at it, and know if you've got growth or decay. Now the way I know that this, what this is I have a base here, something being raised to an exponent. Okay, that base is larger than 1, and the exponent's positive. Okay, so this is growth. Alright, and then this one, this is the base, not the 7, but the e, that's the base. It's again bigger than 1, but because it's a negative exponent, or a negative coefficient on the x, this is decay. Now, don't forget your little handy tool here. Okay, you can put these into your calculator, graph them, and look at them to see if they're growth or decay. Alright, so I've got them put into the y1 and y2 here. This is the 5 to the 0.8x. Don't forget the parentheses when you have multiplication in the exponent. And here's 7e to the negative 3x. Alright, now notice over here I've got the second one bolded so we'll know which is which. Alright, hit graph. I got quadrant 1 on. Once this is done graphing, let me fix this. Zoom standard. Alright, so here comes, there's y1. Here comes y2, the bold line. Okay, so as we move left to right on your screen here, alright, 1's going uphill, that was the first one. Alright, so it's growing, then the other one's coming downhill. So don't forget that you have your calculator to help you. Growth means it goes uphill left to right. Decay means it's going downhill left to right. Alright, question number 3, find the function value. Alright, this is just, do you understand function notations still? Alright, that's a big recurring theme in pre-cal and in college algebra, is do you understand what you're being asked to do? So we're just replacing this x with negative 2. Alright, and then using properties of exponents, that's 1 over 3 to the positive 2. Alright, and then 3 squared is 9. So our answer is a 9th here. Alright, same thing here in number 4. F of x is 1/5 to the x. We want to find f of negative 3. Alright, so the whole entire fraction 1/5 is being raised to the negative 3 power. So f of negative 3 equals 1/5. Right, x was the exponent, we're replacing it with negative 3. So 1/5 to the negative 3. Alright, one of the powers of fractions to exponents, you can flip it over, 5 over 1, and that'll make that a positive exponent. So this is 5 over 1 is just 5, so this is just 5 cubed. Alright, and 5 cubed is 125. Alright, again, don't forget you can do this stuff in your calculator. Come back to your home screen, parentheses 1 divided by 5, close parentheses, raised to the negative 3 power, hit enter. There's 125. Don't forget that you have this calculator here to help you if you need it. Alright, and then for this one, we're going to round it because it's not going to be a perfect whole number, so f of 0.8, it equals 2.8 e to the negative 2.3 times 0.8. Alright, but we're approximating it to 4 decimal places. So just throw that in your calculator and see what you come up with. Alright, so 2.8 e negative 2.3 times 0.8. Notice again the parentheses around the exponent. And then I get 0.4468 to 4 decimal places. That would be 0.4447. Alright, the number of acres in a landfill given by this function, where t is measured in years. How many acres will the landfill have after 2 years? Right, t is measured in years, so we're just going to replace that t with 2. Alright, and then throw it in your calculator, hit enter. Alright, so there's again the function 9200 e to the negative 0.03 times 2. Alright, replacing t with 2, and hit enter, and that gives us this number. They'll only have 8,000, what was it again? 664.23. Nearest acre. So 8,664 is the nearest whole number. Alright, so a lot of these just plugging them in basically. Alright, so here's a couple of theory questions. So why can't y to the 2x have an x-intercept? Alright. Because 2 is positive, and that's the base. There is no such exponent. We can raise and get 0. Alright, we can't raise a positive number to a power and get 0. Alright, what's one ordered pair that's always on the graph of f of x equals a to the x? Alright, so that ordered pair is always 0, 1. Alright, so f of 0 would be a to the 0, and what is anything to the 0 power? Again, a can't be 0, because a, the base, has to be a positive number, so it can't be 0. So that's the only restriction to this rule, but any other number to the 0 power is equal to 1. Okay, so the input is 0, the output is 1. So 0 is 1 is going to be on it no matter what a is. Alright, explain how the graph of y equals 2x plus 1. Let's understand that all of this is the exponent. Alright, minus 1 can be obtained from the graph of y equals 2 to the x. By the way, this is y equals 2 to the x. It's kind of off screen. So basically what happens here is, because this is inside of parentheses being done to the input, alright, this moves left and right. Because it's positive, we move left 1 unit. Alright, and then there's nothing, no minus sign out here, so we're not flipping around an axis. And then this minus 1 moves us down 1 unit. Alright, so it's the graph of y equals 2 to the x moved left 1 unit and down 1 unit. Alright, find the value of the logarithm without using a calculator. So when you have a problem like this and it tells you without using a calculator, what I'm basically wanting you to do is try to get, this is the base. The base is 7. So try to get a 7 out of this number. So intermediately here, I'm going to rewrite this as 49 is the same as 7 squared. Okay? And then I'm going to rewrite that as, instead of 7 squared positive in the denominator, I'm going to write that as 7 to the negative 2 power, because these two things are identical. Alright, now remember, what is a logarithm? The log of this base of this number is what I need to raise this base to get this number. Alright, well this number is 7, the base, to a power, so the power I need to raise 7 to get this is obviously this power. Alright, so the answer here is just -2. Alright, notice also you can use the change of base formula here, which says give me the log of the original input, which is 7 to the -2 power, right, and divide that by the log of the original base, which is 7, right, and then that'll give you the answer as well if you use the change of base formula. Alright, the number of quarters needed to double an investment when a lump sum is invested at 16% compounded quarterly is given by that. Find n rounded to the nearest tenth. Alright, so that's just natural log of 2 divided by natural log of 1.04, on your calculator. Alright, and just hit enter and approximate. Alright, so natural log 2, close parentheses, divided by natural log 1.04, close parentheses, enter 17.67 to the nearest tenth, 17.7. Alright, find the value of the logarithm without using a calculator. So again, this is similar to this problem right here. Alright, log base 10 of 0.01, that's the same thing as log base 10 of 0.01 is 100th. Alright, 100 is equal to 10 squared. So once again, this looks very similar to what we just saw earlier. Take that 10 squared in the denominator, bring it up, and change the exponent to a negative, and now we've got the same base here and here, so our answer is just that exponent. Alright, same thing going on in this problem. ln e to the fourth, ln is the same thing as the log base e of e to the fourth, and once again, same number here as here, just like we had here. When they're the same number, the answer is the exponent. Same number, so the answer is the exponent. Alright, here you have to excuse me, on this problem in particular, you just have to understand ln is log base e. Alright, solve the equation with an exact solution. Okay, no decimals. So anytime they're wanting to solve an equation like this, what we need to do is isolate the log part. So there's our log part. So we want to isolate that, meaning we want to divide away this 3 first from both sides. Okay, so it's gone. Now we've got just the natural log of x is equal to 10/3. Now, this is the way I do this problem. Is I would at this point rewrite it as the log base e of x equals 10/3, and then change it to exponential. And by that I mean take the base, go across to pick up your exponent. Remember, logarithm is an exponent, so this is the exponent, and then go back across to set it equal to what it's equal to. Alright, so by that I mean e to the 10/3 power. Alright, this is the base, this is the power, equals, alright, and then go back across the equals x. So we've solved it. There's our solution. Alright, remember, you want x isolated, we just isolated it. And a lot of times just changing it to exponentials, if the input in the logarithm is just by itself, changing it to exponential actually does solve the equation. Alright, but again, you have to understand that ln is the log base e, so you can do this. Alright, in a case like this, it's not as easy. We have a log on each side of the equation. So what we're going to need to do here is group the logs together onto one single side of the equation. Alright, so added and subtracted the log x, so they're gone. So what I have now is the log base the log base 10, or just common log, of x plus 3 plus the log of x is equal now just to 1. Okay, now we're going to use a log property. It says if I have the same base log, and I do here, both of these are the common log, I can multiply the two things together on the inputs, meaning x times x plus 3 into a single log. Alright, now just like we did up here, natural log is log base e. Common log, meaning if we don't write a base down here, is understood to be 10. So I'm going to stick in a 10 right here. Alright, and then I'm going to do exactly what I did in the last problem. This is the base. We take that across to that power and set it equal to what's in the parentheses. Alright, so that means I'm going to take 10 across to the first power, that's my exponent, equals all this stuff in the parentheses. X times x plus 3. Alright, now distribute your x through here. You got x squared plus 3x equals 10. This is a quadratic equation. So how do we solve that? We set it equal to 0. And factor if we can. This one will be factorable. So we're going to subtract 10 from both sides. Alright, I end up with x squared plus 3x minus 10 equals 0. Alright, that will factor. I get an x and an x. Alright, I need two numbers that multiply to negative 10 and add to positive 3. So that's going to be a positive 5 and a minus 2. Alright, and if these two factored pieces multiply to 0, then I get x plus 5 equals 0, or x minus 2 equals 0. Right, add 2, x equals 2 is one potential solution, subtract 5, x equals negative 5 is another potential solution. Right, now remember, with log equations, just like with radical equations and rational equations, you have to check your solutions. So these are my proposed solutions. Okay, now, right off the bat, going back into the original, if I plug in negative 5 into this equation right here, meaning the log of negative 5, my calculator says I don't like that. Okay, we can't put a negative inside a log, so immediately, because of that right there, I lose this solution. It is not a solution. Okay, but we do need to check the other one to make sure it does work. You always need to check these. So let's put in the log of parentheses. Other solution is 2, so 2 plus 3. See, hit enter to see what we get. Alright, and then check log of 1 minus the log of 2. That's our other solution. And we get the same thing. So that one does work. Alright, so that's the only solution. So you have to check. Anytime that we use these property logs to multiply things together, we run the risk of these extraneous solutions, these things that work out as a solution, but don't check in the original. So you always have to check. Alright, I'm going to do the same thing here, except we're going to use even a nicer property of logs here. Alright, so I'm going to combine these two, same base log, so they can be combined using this time the quotient rule, because we have subtraction. Alright, we can combine these with that same log, natural log, and then parentheses, this is going to be our numerator, this is going to be our denominator. What are they equal to? They're equal to this still. Alright, now we're going to use a property that says if you got a log equal to a log and it's the same base on both sides, so this is base e log, or the natural log, this is too, so this means that we have the exact same base on both sides, we can just drop the bases, okay, and just set the inputs equal to each other. So I'm going to say x over x minus 2 is equal to 8. Alright, and then just solve this thing. Alright, how do I solve it? Clear fractions. So I got x equals to 8 times x minus 2. Alright, I just multiplied both sides by x minus 2. Alright, it canceled over here. So that's where the x is coming from. And then we're going to distribute this 8 through. Alright, so x equals 8x minus 2. Alright, isolate the x, and I've got negative 7x is equal to negative 2. Divide away your negative 7. X equals 2/7. Alright, and then throw it in your calculator. Make sure you check it. So I'm going to write this time 2/7. I'm going to store that as x. Hit enter. It's going to give me the decimal approximation of it. And then I'm just going to rewrite my original equation. ln x, close parentheses, minus ln parentheses x minus 2. Hit enter. It tells me I get a non-real answer. So where's it coming from? Where's the problem? It comes from the fact that 2/7 minus 2 gives me a negative number, and because of that I'm getting no solution here. Alright, so the only thing that worked doesn't work. Alright, the only thing that could work didn't work.